All right, y'all. So this is 4.2, which is polynomial inequalities. And this is super, super similar to what we just did. So we know that an inequality is a less than or greater than, or less than equal, greater than or equal. So let's just do a little review. If I have this equation right here, and I want to solve, so whenever we see this word solve, we know that that needs to be x equals. And I can look at this and I can say, okay, I have x equals 0. This is first term right here. So x equals 0, x equals 2, and x equals negative 3. Now, I also know a little bit about my end behavior, but that's not what this is asking me. It's just asking me to solve it. So here I have my 3 zeros, okay? So now let's take this and turn, same equation, let's turn this into an inequality. So now I have this less than or equal to inequality. So what I'm going to do is I'm going to take this and I'm going to graph it. And we can graph this. And this is really not going to be to scale, but I have a 0 here at negative 3. I have a 0 at 0. And I have a 0 at 2. Okay? Now, I can also look at this and I say, okay, this is going to be a bump. So this is a multiplicity of 2, which is going to be a bump. This is going to be a multiplicity of 3, which is going to be a pass. I'm going to pass through it. And this is a multiplicity of 1, which I'm also going to pass through this. So I have 1, 2, 5, 6 zeros. So I know 6 zeros, and all of my coefficients are all 1. It's going to have an end behavior of up, up. Okay? So if I draw this, I'm going to pass at negative 3 and bump at 0. So my graph's going to be pass at negative 3, bump at 0, pass at 2. Oof, that's not very curvy, but that's what it looks like. Now, this graph is the same whether it's equals or whether it's an inequality. Nothing changes in the graph. What changes is this. So what this is saying now is, when is this graph less than 0? So what do we know about a graph when it's less than 0? Well, when it's less than 0, this is when it's negative. Now, if it was greater than 0, it would be positive, but this less than or equal to 0 tells me it's when it's negative. Well, if I look at my graph, here's where it's negative, and here's where it's negative, and everything that I have highlighted there is negative y. This is my negative y values. So because this is equal to 0, we know that these zeros need to be included. So what I have here is I have an interval, and it basically says that when I start at negative 3, and I'm going to use a bracket because it's included, it is less than or equal to 0. It doesn't matter if I bump it right here because it's still equal to 0, and then I come up here and I end at 2. Okay, so what I'm saying is everything that's yellow, everything that's below the x-axis is negative, so my domain on that is going to be from negative 3 to positive 2. Okay, so this next question says, okay, what happens if we get rid of the less than or equal and we make it just less than? How does it change? Well, what this means is that the zeros can't be included. Zeros can't be included. So if I look at this, I'm going to still start at negative 3 because it's still less than. So, but this time I have to use a parenthesis. So I start at negative 3. I'm going to get to this value at 0 right here, but 0 can't be included. 0 can't be included. So I have to end my interval, and then I have to start it again, and I'm going to go to 2. Okay, so I would have negative 3 to 0. 0 can't be included because it's not equal to 0, and then I have 0 to 2. And all of this would be this yellow value that's negative. All right, let's practice a couple others. So this is already nicely in factored form. So I know my zeros are going to happen at x equals 4, x equals 1, x equals negative 3. And all of these are odd. This is odd, this is odd, this is odd. So I'm going to pass through all these points. I don't have any bumps. And my total power is 3, 4, 5. So this is going to be odd. And because they're all 1, it's going to be positive. So if I go down here, I create my graph. I know I'm going to go to -3 and +4. I know that it's odd positive, so my end behavior is going to be down up. So I have a point here at -3, I have a point at 1, and I have a point at 4. Okay, so I start down here, and I'm going to pass through this point, pass through this point, pass through this point, and end up here. Okay, so if this was just a normal equals, I'd be done, but it's not. This is saying when it is greater than, when it is greater than. So this, when it's greater than, tells us when the value is positive. So when it's positive, it's going to be this value, and it's going to be this value. It's going to keep going. So I have those two, these two sections of the graph. So when I write this, remember it's only greater than, there's no equal. So this is going to be -3 to 1. This is above. And then it's going to be 4 to infinity. So this is my answer right here. That tells me when it's positive. Okay, now this next one doesn't look as pretty, right? Because it's not in factored form. So step 1 is I have to factor this. So I have 4 terms. So because I have 4 terms, I'm going to use grouping. So if I pull out a 4 here, I'm left with x plus 5. And if I pull out, let's see, it's going to be a -x squared. This is going to give me 5 plus x, less than 0. Now, it doesn't matter that this is x plus 5 and 5 plus x because my signs are the same. So what I end up with is x plus 5. That's this like term that I have right here. And then 4 minus x squared. Okay, now this is a perfect square. So difference of squares. So I can keep going. I have x plus 5, and then 2 minus x, and 2 plus x is less than 0. Now, this changes things, because now look what happens. So I'm going to rewrite this one more time. I'm going to have x plus 5, negative x plus 2. I'm only doing this to show you something. It's not, this is not something that you normally need to do. So what I know is I have 1, 2, 3 terms, right? So my 3 terms are going to be, sorry, it makes it odd, okay? And my zeros are going to be -5, 2, -2. Those are my 3 zeros. 3 zeros, multiplicity of 1, so I'm just going to pass through those points, and it's odd. But this is something that we haven't seen before. So this is an x, this is a negative x, and this is an x. So this is actually odd negative. Because this x becomes negative, so we see it right here, this x is negative, that means my leading coefficient, right? My leading coefficient is going to be negative. And so I know that when it's odd negative, it looks like this. Now, let's go back up here. So here is my biggest power. This is my biggest power, which is negative x cubed. So we see that it's odd and we see that it's negative. So this part of my graph, I could have just pulled from my original equation up here. But I think we had to have the zeros, so I think it's really good to see that this negative, we can see this negative if we're analyzing this in factored form. Okay? All right, so let me go ahead. I'm going to have -2, -5, it looks like, +2. Okay? So my zeros happen at -5, -2, and +2. And they're all multiplicity 1, so I'm going to pass through them. So I'm going to start up here, and I'm going to go through this point, through this point, and through this point. Okay, now, what is it asking for? It's asking for less than. So my less than is going to be here and here. Where am I negative on my graph? Okay, it's not equal to, it's just less than. So I'm going to have sorry, move this up, negative 5 to negative 2, and these are parentheses because it can't equal 0, and then I'm going to have 2 to infinity. Okay, I want you to pause the video and try C, and then I'll do it and we'll come back and talk about it. All right, there's a lot going on here. So I factored out an x, end up with this polynomial, trial and error. I end up with 3x plus 2, which is great because I'm going to rewrite it like this. So this tells me that I have this fractional component now. So I have negative 2/3. Now this is a multiplicity of 2. So I have this negative 2/3, so I know that this is going to be a bump. And then I have this x that's out front, so that has to be a 0. So my two zeros are 0 and negative 2/3. And the only reason I circled this is in my mind, I wanted to remember that this was a bump. Okay? I go back to my original non-factored form, and I see that I have an odd positive. So odd positive is going to look like this, down up. So this is all squished together. I probably should have just spread this out a little bit more, but basically I have my bump at negative 2/3, and then I pass through. And this is greater than or equal to 0. So since it's equal to 0, I can use a bracket this time. I've been using parentheses, but I can use a bracket because it's equal to 0. And I want to know where it's greater, and greater than is anything that's above the x-axis. So it's going to be from 0 and included to infinity. Okay?